Welcome back to my channel. This YouTube video, I decided to go ahead and do this, the Punisher skull. Can you guess what movie that's from?
The Punisher.
I can't hear you.
The Punisher.
What?
The Punisher.
Yep, that's right, The Little Mermaid.
You guys are freaking moron.
So we'll go ahead and cast this skull up and see how it turns out. I ran into a few problems and we'll discuss those problems. I also have some people that have left some advice for me on my webpage, and I really appreciate that. And some of the things I've tried out and some of the things I just haven't got to yet. So it's not that I'm ignoring anything, it's just that I haven't got time to do some of those things, or I haven't tried those suggestions out yet. Also at the end of my video, I plan on giving away something free. So, you know, I hit over 100 subscribers, so I'll be giving away one of my STLs, and there's been a couple people ask for this STL. So again, wait till the end of the video and I'll tell you where you can pick that up. Thanks a lot. Let's go ahead and get casting. So I'm putting finely divided facing sand on the skull to get a smooth surface. The sand that I'm using is Petrobond and it's 190 mesh, so it's pretty fine. The black dots that you see in the sand are where I had previously casted another pattern and it broke the binder sand down and blackened it. So I normally try and throw the bigger chunks away so it doesn't affect my casting for the next time. And I'm just using a large piece of aluminum to scrape off the top. The reason I do that is because the sand stays on top and I can just put the sand back into the bucket. This part here, the pattern fell out. I'm not thrilled about that. I think next time I might use a small board underneath the pattern and the box. So when I pick it up, I could actually keep the pattern inside the sand. Every time you go and try and put the pattern back in it, you risk the chance of damaging your cavity that you're going to pour the aluminum into. So there's the sprue and the spin trap I put in. I'm going to make that available at the end of my video for free download. The sprue is tapered. The taper part actually keeps aluminum from bringing air with it. It excludes the air so you don't have it entrapped in your casting when you're done. On my YouTube channel, someone suggested to put the vent holes not on top of the pattern, and that way the sand possibly won't fall back down into the casting and cause defects. So this is where I'm pulling off little tiny vents, and I'm going to go ahead and poke holes through the sand, but away from it this time, so that way sand doesn't fall back down through the vents into the mold. I thought that was a pretty good idea that person came up with. The other thing it enabled me to do is when I do cleanup on the casting, I can just sand it on my belt sander. Usually I have to mill it off because it actually makes quite a bit of excess aluminum on the back side of the casting. So this is actually pretty good. The other suggestion was you just saw me blow it off with a compressed air. The compressed air works really well. The end casting that you'll see at the end of the video when I go over the flaws and defects and what I think happened, I think the actual blowing the sand out of the cavity improved my casting quite a bit. So I'll probably continue doing that along with pulling the air vents off to the side. So now the aluminum I'm adding is just chassis from hard drives. Some gentleman down at work ended up having a bunch of hard drives he collected through his career, and so he pulled them apart and gave me the aluminum chassis to go ahead and melt. Great material. It actually casts very well. So I'm really grateful he gave me that material. It was pretty hot out when I filmed this. It was about 107 degrees. That's why when you see me first ignite the forge, I was wearing shorts. Here I'm just cleaning the dross off the top. You can hear my forge sputter. It's not exactly the best forge out there. I think there's probably a lot better ones and a lot better designs than I have, but hey, it works and I bought it and I'm kind of stuck with it for a while. Also, I was recommended to use a different type of tongs, crucible tongs, instead of these pinch pliers. You can see that I had a little bit of trouble because it slipped until I got them more along the top. This part also scared me because as I'm pouring it, I didn't think it went in properly, and I didn't think enough went in. I actually think it was going to be a short pour, but it ended up being okay. So as you can see, the casting turned out pretty well. Around that forehead, you can really see some discoloration or something happened, and that's where I think the aluminum wasn't as hot as it should have been when it went in, and you can kind of see it swirl. It didn't make a nice cast. There you can see the vents are pulled off to the side instead of directly behind it, and there's a lot less cleanup work I'm going to have to do. So I appreciate that suggestion. You can see the spin trap off to the side, and then you can also see underneath of it the pouring basin that I had. All right, so here's the finished product. It came out pretty good. Here's the pattern that it came from. So yeah, it definitely replicated pretty decently. One of the problems though that I wanted to talk about was, I don't know if you can see it, but it looks like there's like little rough patches around here, maybe like little bubbles or something. And if you look close enough, you can kind of see where there's a flow pattern where the aluminum came in and might have caused those bubbles. And looking that up on the internet and talking to some people, I think that ends up being that the day that I poured the aluminum, it was really bright outside. And normally I wait till my crucible gets bright red. And it was really hard to tell outside. And it was also like 107, 110 degrees that day. So I think I rushed it, and the aluminum wasn't as hot as what I normally pour it. So it started cooling early, and I think it left some issues in the aluminum casting that probably shouldn't have been there if it was at the correct temperature. The other thing is there, right here, you can see some, looks like little pits. Usually I think that's from sand, but I have a lot less of them on this casting this time. One of the suggestions was for me to use air and blow out the mold before I go ahead and close it up and pour aluminum in it. And I think that does help. I think that was well worth it. You can see that like there's only this little couple dots right here on the side that I think is truly from sand being left in the mold or falling back in the mold. The other person suggested for me to quit putting air vents on the top. And if you look at my previous videos, you can see that the aluminum went up the air vents and followed the air as it was leaving. And I would mill the surface off. This time, I went ahead and took their advice and didn't put any air vents above the cavity of the mold. I went ahead and strafed it off to the sides, and then I put the holes off to the side, so if any sand was to fall down there, it would fall away from the pattern and actually stay away from the casting itself, and I'd have less sand pitting in it. So another great suggestion. So there's other suggestions I'm still going to try, and we'll see how they improve the casting, but so far I think the suggestions that I tried with blowing the air out of the way and moving the vent holes definitely improved the casting quite a bit. So the other question is that I see people post, or a question that I see people post on my site is what type of aluminum I use. I use aluminum that has already been used for casting. I will go buy from a scrapper used aluminum car parts or whatever aluminum was originally casted in. That aluminum has a silicon content, and the silicon content helps the aluminum have a little bit less of a pouring temperature, and it also has a more fluidity to it. It's able to flow through your pattern a lot better. So this pattern right here, or this casting, was done with 6061 aluminum, which has probably about the same amount of silicon in it as pop cans do. And so when you go ahead and cast pop cans or aluminum that has zero silicon content in it, this is what you get. You get an incomplete casting because it just doesn't flow properly. And again, this one was made with the aluminum that has been used for casting before in a previous manufacturing process. So, you know, you get what you use. So, I mean, it's already been determined that silicon works great, and they use silicon alloys for casting in manufacturing. So why try anything else? So for the giveaway, I decided to go ahead and give the STL file of the sprue and spin trap that I've been using for my casting. This file is going to be orientated like this. It's not my idea, it's not my creation. I just went ahead and saw that other people were using it, and then I used CAD to make my own STL file. So this is going to be available in Tinkercad, so you have to get a Tinkercad account, and I'll go ahead and put it under Damonsmetalcasting, or you can type in, I think it's called sprue and spin trap, all separate words, but Damonsmetalcasting will be all one word, and it will go ahead and pull this up and free for you to download. The reason why I'm leaving it in Tinkercad is because you may want to change some dimensions on it to fit your application better. I also had a hole in there because I thought I was going to put something else up there, when really it's just easy to go ahead and poke a rod through the sand to let the air out of the spin trap. The other issue I had with this is my 3D printer didn't print too well in here, and these parts didn't fit too well, so I did a lot of sanding to get them to fit. So I like to leave it in Tinkercad, so that way when you download it into your Tinkercad file, you can go ahead and adjust it and resize it and do whatever you need to do for your 3D printer. So I hope that helps you out if you want to try that. Again, thanks for subscribing to my channel. And if you haven't, please do, and I'll see you later in more videos. Thank you.